All right, this is the 2024 FRQ problem number 2. And so problem number 2 is a calculator allowed problem, and they will always give you 2 data points to begin with. So this one says, on the initial day of sales, t equals 0 for a new video game, there were 40,000 units of the game sold that day. 91 days later, there were 76,000 games sold that day. The number of units of the video game sold on any given day can be modeled by this equation, where g of t is the number of units sold in thousands. So the 2 ordered pairs that they give us are 0, 40, and I don't have to write 40,000 because g is already in thousands, and 91, 76. So part A is always this. Use the given data to write 2 equations that can be used to find the values for A and B in this expression. So part A, I'm going to show my work. I'm going to put my work down here. So part A, what are the 2 equations? So it was, just so I don't have to scroll, it was g of t equals A plus B ln t plus 1. So put in your 2 points. One had a y value of 40, an output of 40, when the input was 0. So here's one equation. And the other equation had an output of 76 when the input was 91. Now, you could try to solve for these algebraically, because what is the natural log of 1? That's 0. So you can get A equals 40 and then plug 40 in here and go through and solve. Or you can always solve these with regression. So for part 2, I'm going to say use regression. Now, here's the problem, though. If you use regression with the points 0, 40, and 91, 76 on your calculator, you'll get an error. And if you use Desmos instead, you can tailor the Desmos equation to give you exactly what you want. So here's what I mean by that. So let's switch over to Desmos. I first want to enter the 2 points into a table. So to do that, you're going to click the plus sign, table. So our first input was 0. Our second input was 91. Our first output was 40. Second output was 76. So when you enter in a table, it will give you this little add regression feature right here. And this is true on our AP test as well. Down here is zoom fit. So that will take you right to those 2 points. I think that's smart to do. Now, if I click regression and I just try to pick, they told me to do a log regression, there's an issue here, right? It says logarithmic regressions only work if the first column is all positive numbers. You can't have a 0 right here. Now, you could put in 0 plus 1 and 91 plus 1, and it will give you the correct answer. But that's not exactly the model they wanted. So here's how I do this. Put in the original data. Don't mess with it. Ignore this regression. We don't really need that regression. You don't have to choose a regression option from this table. I want to type in our customizable one. I want it to be y equals a plus b ln t plus 1. We have to write x plus 1. Okay, but this is saying like what's happening here. Here's what you have to do. You have to call it y1 because that's what our table is. So click, I'm typing in underscore shift dash underscore y1. This has to be x1 shift dash underscore y1. And I can't have an equal sign here. To make it do a line of regression, you have to use the tilde symbol, which is shift. It's this little symbol here. This is to the left of my 1 on my keyboard. So this is the exact equation they want. So here's A and here's B. So I'm just going to split screen this. Put this on the left here. And so I like to say, instead of just giving A and B, I like to at least tell the person who's grading my work, I used regression with these 2 points, and I got A equals 40, and I got B is about equal to 961. And that's because you have to round to 3 places, remember. If you do not round to 3 places, they will count it wrong. if you round to more than 3 places or less. And that's because the directions tell us to round to 3 places. So are you following the directions or not is part of what they're looking for. So these are my values for A and B. You don't have to put it into the model, but you can. G of t is equal to 40 plus ln, 40 plus b, 7.96145 is what it technically is, ln of t plus 1. But here's A and B. The only reason I like to write it out like this is because I'm going to have to graph this model for a later part of the problem. Okay, let's look at part B. Part B is not dependent on the model you just found. So part B always says use the given data, which means use the points that they gave us, to find the average rate of change, the AROC, of the number of units of video games sold in thousands per day from 0 to 91. Express your answer as a decimal approximation. Show computations that lead to your answer. So you have to show your work. Remember our formula for AROC. AROC is just a slope between 2 points. We're using these 2 points here. So it's 76 minus 40 over 91 minus 0. And again, I can use you're allowed to have your graphing calculator. Oh, I probably need to sign into this. Sorry. I'm not going to use my graphing calculator because it's not signed in. You can still just use Desmos. So if I can find it, get off of that. All right, so I want to know what that comes out to. So that was divided. So 76 minus 40 over 91. You can round this to 3 places for your answer because it wants the decimal approximation, but remember not to round it when you're computing things with it. So it's 0.396 approximately. And the label on that you don't have to label it for the points, but the label is, what did it say? In thousands per day, or whatever, 1,000 units per day, but I'm just going to leave it like this. Okay, and then part 2 says use the average rate of change that you just found to estimate the number of units sold on day 50. Show the work that leads to your answer. So this is always a point slope equation. So in general, you have y minus y1 is equal to m times x minus x1. In our equation, m is 0.395 ... because we're going to use the unrounded version. X1 and y1 can be either one of the 2 points. So I'm going to use the point 0 and 40 for my x1, y1. I'm going to say that's 0, 40. But you can also use 91, 76. So it'd be x minus 0, and over here it'd be y minus 40. Okay, and then we want to find y of 50. So that's 0.395 ... times 50 minus 0 plus 40, because you have to add that over. And so I can, again, do this in Desmos. So I could say, all right, what is this answer that I got? Copy, paste, times 50 plus 40. It's 59.780 to 3 places. So it's about equal to 59 points. Get this off of here. 780. Again, that would be thousands of units sold, so we don't need to round that to the nearest unit. In a practice test, we rounded to the nearest plant because that made sense, but you can have decimals of thousands. All right, and then part 3, I think this is always the hardest question to answer, part 3 of B. So this says, let A of t represent the estimate of the number of units of video games sold in thousands using the average rate of change you just found. So in general, that's just saying A of t is just your linear equation. A of t is just equal to the 0.395 ... times x minus 0 plus 40. That's the general linear equation you just got from right there. Okay. For when we plugged in 50, this number is less than what our model would give us for 50. Explain why in general that for any value from 0 to 91, the linear approximation will always be less than g of t. So this is almost always answered just via graphing. So just graph the two things. Let's see. We already have g of t graphed. That's this curve. Let's go ahead and graph our line for a of t. So let's go ahead and graph y equals, it's okay to round here, 0.396 x minus 0 plus 40. So what's happening on 0 to 91? 91 is like here somewhere. If you needed to reset the window, you could change it to say, okay, from 0 to 91. So in this section here, the line a of t is always sitting underneath the curve. So why will the approximation always be less? Because graphically, g of t is above a of t. All right, so on this section, I would say you could even sketch the graph if you want to. Just make sure that you actually label the two graphs and give a semi-accurate sketch. So it's like something like this. Here's the line. Call that a of t. And here's the, here's the natural log equation. So that's g of t. So you could sketch it like that, but you don't have to. You could also just say on the interval 0 to 91, a of t is below g of t. So the approximations are always going to be lower. Now you could say something maybe about the concavity. G of t is concave down and increasing, whereas a of t is just increasing. But I don't know if you have to say that. Sometimes they want us to throw in concavity. So maybe I'll just say everything I know about that. I could say g of t is concave down and increasing. While a sub t is linear. All right, and then what about part C? Part C changes slightly from test to test. So one of our practice tests, it was more of a domain question. This one says the makers of the video game reported that daily sales of the video game decreased each day after t equals 91. Explain why the error in Model G increases after 91. So this is because the error is saying like we have this concave down. Let's take a look at our graph again. After 91, see how the line is overtaking g of t? So this g of t, it slows down how it's increasing, whereas the line the linear approximation increases a lot faster. So this error is just going to keep getting bigger and bigger and bigger. So for part C, I could say g of t decreases more slowly for t greater than 91. So the error will continue to increase. It's not decreasing as, or it's not increasing as quickly as it should for what's really happening with sales. Right? All right. Like I said, number 2 is by far the most difficult question, just because you have all of this like writing and explanation, and there's not just a set, you always answer it like this or you always answer it like this. So this is the most challenging question, but I would say that you should be able to, with regression, do parts A and B1 and 2 perfectly. It's just part 3 and C that get a bit tricky. So that's just 2 out of the 6 points that are a bit iffy. But you should be able to get 4 of them pretty solidly locked in.